cool stuff that I want you to play with. Sort of.
We had sushi.
If I can get the answer fast enough, then I know, you know, it's kind of no, that's the reason I'm sitting right here because I've focused my, you know, every publication needs it, I guess. I don't even know if they do it, but at one point used to see that. It doesn't
So it's on and off?
This will capture that.
Yeah, top 15. What is it? Nobody knows. Right? So this to me is like, because people I work with say, well, what gene can we knock out to fix the problem? Yes. And then I work like that. It's probably some ebb and flow of the whole thing. And that's where this to me is like ridiculously powerful. Because right now all we get is tables or somebody will give you a full channel. What's even what 10 people are just thinking about? I'll say ones I think I know, but I want to know what the other like 4,000. For all those wise things, nobody knows what to do.
Yeah. I mean, and you're dealing with a situation where you can read in the whole thing.
Oh yeah, that's right. That's somebody sitting working.
Oh, actually, string.
Yeah.
Choose E. coli.
Okay.
Go through. File. You have to string.
Oh, you'll be using this?
Yeah, I'm going to be sitting this
Oh, okay, cool.
really.
Just make sure that we're hearing you.
It's different from the morning session we were doing. This is
Public data.
Okay, just if you know something far off, please. There's a little switch on the top. No problem.
Okay. Change to E. coli. All right, so just search for it. So fine. Yeah, give me 1 minute.
We'll get started in another minute or two. In the meantime, we have lots of helpers, so if you have questions right now, just raise your hand. We'll take it to one-on-one questions, and then we'll dive into our.
Change whatever class you want.
And I'll use the microphone.
Yeah, sorry, when people are asking questions.
Now, you have an email network with everything. The whole way, look. You'll get all of,
I'm good. Wait, that's fine.
all of the proteins and all of the known interactions. And all of the spores will be down there just like you saw.
And this is curated from
Multiple databases, multiple, this is string DB, which is pretty, you know string DB.
Okay.
Perfect. So, so there's 3 options. I'm one. So you have people that you can
Cool.
and the other one is Lars, who's actually
Okay, great.
give you. I've
Hey, hell of a start.
yeah, this will give you something really huge network.
I'm sure.
Obviously.
Yeah.
But then what you want to start doing, what I would do, that now
it? We're gonna get hands-on. And we've been instructed to use the microphone when we're walking around for the recording, not just to reach the rest of the room.
Oh, sorry.
We were scolded, so sorry about that. So help us remember that if we forget.
I don't think it's turned on.
And it's not turned on. So we've been instructed to turn on the mics when we're going to use them for recording, even if our voices carry in the room, which is all I usually think about. So, but for most of this, I'm going to be sitting here and doing hands-on. But if you come up with comments, I don't know if you want to carry this around just in case.
Not particularly, but I will.
I won't make you wear it, but I'm going to ask you to carry it. And let's dive in. Okay, so here we are in the slide deck. If you're following along, we're on the last section of Cytoscape automation. Is it not loud enough? Okay. So again, just a couple slides here, and then I promise we really are getting into hands-on in R in no time. So this is a brief history of Cytoscape automation. In the beginning, there were commands. These have been around for a while. The syntax looks like this. If you want to know, if you want to get the list of nodes in the current network, you would literally type node list network equals current, and you can do this. There's a command line dialog in Cytoscape, and you can type these sorts of commands and write scripts using these sorts of commands, and Cytoscape will run them. That support's been there for a while. The big advance that we had, thanks to Barry and others in the room, was CyRest. We've mentioned this a couple times. This is, if you're familiar with REST and RESTful interfaces, that's what this is. And the syntax looks like this, right? Everything's a URL for the same function of getting the nodes in a network. And here we have unique session-unique identifiers for networks, and so you'd need to provide that as part of the syntax. And this is how you'd perform that same operation. CyRest supports a number of functions that operate in Cytoscape. It also supports the commands that have been in Cytoscape for a long time. So there's sort of a couple routes via CyRest that either operate through this sort of syntax or through some new syntax. And so with this, you could write scripts now in any programming language that supports HTTP protocol, which is pretty much any programming language. So that's great. You always have that access to Cytoscape from any programming language. But on top of that then, we built a couple helper libraries or helper packages, one for R called rcy3 that we're going to be using a lot today. And then there's one called pi2Cytoscape for Python. So all of these, all they do is they're basically wrapper functions that make the syntax more familiar to Python or to R users. Yeah. Good question. I'm not sure. Does anyone know if pi2Cytoscape is compatible with 2 and 3? I think so. But it's definitely compatible with 3 because it's been developed in the last year. I don't know what its backward compatibility limitations are. Yeah. And so these 2 packages offer wrapper functions or helper functions you can do in 1 line what you could otherwise do in 5 or 10 lines. And so that's where we're going to focus. If there's anything these packages don't cover, you can always go back to calling REST commands directly. And so if that's something you're familiar with and comfortable with, you can just use that. But otherwise, we recommend these harmonization or helper packages. Okay, this should be pretty familiar to you all already, but when would you want to use these automation? We showed a few UI interactions with Cytoscape. So when do you switch from doing that to writing scripts? Some of these functions are a few menu clicks away. If you had to do something 100 times, that's when I'd recommend writing a script instead of doing that manually. Before automation, we've all been in the spot where you had to do something almost 100 times, and it's not a lot of fun.
And so scripts are great for that. Obviously looping through things where you want to change a variable slightly. Barry was mentioning earlier that the animation potential of Cytoscape is not only available from the Cyanimator app, which is commandized, but you can also, with scripting, you could animate however you want as well. You can control the position of nodes, the colors of nodes, and so with a for loop, you can create interactive displays that run as your script runs. Recording those is another issue. And then the other thing I really want to make the point of, reproducibility is a hot topic right now in all of our fields. And so reviewers are getting a little better at this, but they really should be requiring that you provide a script when you have done an analysis. And so we should all get in the habit of, even if you've done it manually, of trying to record it in a script form so that you can do it again 6 months later and not forget how you did it, but then you can also share your results properly with the community so that they can reproduce what you've done and build on it. And so scripts are great for that. Okay, so we're going to walk through, together in a hands-on format, we're going to walk through a couple of the vignettes that we've prepared for the RSci3 package. Then we're going to have a period of time where you can work on any script you want, your own script or other vignettes we've had prepared, or some of these. So we have our scripts, we have these expanding collection and a couple GitHub repos of R scripts and Python scripts that use Cytoscape. These have been contributed by folks like yourself and our own central team. And so these two items are actually links that'll take you to those repos, so you can go to those from your slide deck when we're at that period of the hands-on and see lots of material. There's well over probably 4 hours of material in these repos already, and they're growing. And if you want to contribute a script that you either publish or work on as a toy example later, please do. We'd love to collect more of these. A quick note about the sort of an overview of what the RSci3 package is, an example what it covers. It covers a lot of different things. Let's see if I can get rid of this. Oh, you know what? I think I captured my mute in the screenshot. I just made this slide. I just made this slide during the morning session while Scooter was talking, and so I wasn't very careful. I'll update this later this afternoon. That's kind of funny. Okay, so there's a lot of different categories of functions that are available in this package. There's about 280 functions in the RSci3 package, and so hopefully this slide is a way of trying to wrap your head around everything that's in the RSci3 package. So I'll talk about a couple of these as example. There's app support that's coming in 3.7. So this is actually, we have the commands ready and the functions are ready, but Cytoscape 3.6.1, which you all have installed, that one doesn't support these quite yet, but these will be coming in 3.7. There's commands to support interaction with index, and we have a vignette that we can go through this afternoon to show you how to interact with index, which is a database that can store your networks that you're working on, and it's a great public repository of networks, but also a private repository for networks you're working on. You get to choose the sharing permissions. It's kind of like a Dropbox for networks. Think of it that way. If you want to store a collection of networks on the cloud and share them with your colleagues, that's a great way to do that. And so we have functions to make importing and exporting really easy in your scripts. There's support for groups or meta nodes. All the layouts can be automated. Here underneath my mute sign, there's a long list of network, node, and edge functions. The key ones that I think are really helpful are in the style area, and you see I've even broken these out into different sections. So there's defaults, mappings, and bypasses. Hopefully that sounds familiar, right? Those are those 3 columns that are in the style panel. defaults, mappings override defaults, bypasses override all of those things. You have functions to control each of those values for individual nodes or sets of nodes in this package. Anything you might want to do with tables, right? Cytoscape works with networks and it works with tables, and then the styles bring those two together. Anything that's in the tools menu, including the diffusion options. We don't have network analyzer in there yet, but that's on the list. And then even user interface items like the panels, hiding them, showing them. So if you want to actually be displaying, if you want to display Cytoscape and give yourself more screen real estate in a script, you can do that. So we've tried to include every possible control. There's a few we know that are missing, like network analyzer and network merging are a couple that are still on the list, but I think we're over 90% there. If you find something missing, you can let us know or report it as a bug in the GitHub repo. Okay, so that's the first overview of this RSci3, just to give you a sense. We're going to dive into that in more detail in a second. The last thing I want to show you on a slide is is automation of apps, right? So we now are familiar with the core of Cytoscape, but there's also 330 apps that have been developed by other folks. We've been encouraging them over the last year to add automation support, and they've taken it up in large numbers and are publishing about them. This link will take you to, let's see, I'll just go there, to a collection of articles at F1000 Research dedicated to apps that now support automation. And so you can scroll through this collection of articles and learn about how each of these particular apps, what commands they support. And this collection has about a dozen articles in it now, and that'll probably double over the next few months. So you can keep an eye on there if you're wondering what apps support automation. Okay, that was the last slide. Great. Okay, so now onto the hands-on. Hopefully you all got the pre-workshop instructions and have Cytoscape installed. You have RStudio and R installed. The latest versions are needed for the RSci3 package. And so that was step 3, was installing the RC3 package. Who here is familiar with R and uses it in their work already? Okay, that's good. Who prefers Python over R? Okay, great. So for you folks, if you want, you can install the Pi to Cytoscape, and as I'm going through the R examples, there are some analogous Python examples that you can find in the Pi to Cytoscape manual, and so you're welcome to do the Python version of this. We have to pick one to sort of demo, and the majority is typically and is today R, so that's the one we're going to go with. But definitely during the free period, feel free to focus on Python examples, and we can help you get through those. Okay, and then again, as the pre-workshop instructions, we had you go through this overview vignette. So let's do that right now just to make sure we're all caught up at the same place. What I'm going to do is I'm going to have Cytoscape kind of small up on the side here, just so that we can kind of see it running as I'm running through the vignettes. There's a couple of ways to do the vignettes that you have available to you. One is this HTML view, which sort of looks nicer. Let's see if I can make it a little bigger. Right, so the HTML view of the overview vignette looks like this, and you can simply copy paste each of these chunks, code chunks, into RStudio or into an R command line and run them. That's one option. The other option is to download the RMD source file and load that into RStudio. And this is what that same vignette looks like in RStudio. The nice thing about this view is there's little play buttons, right? And so I can just click play on each of these code chunks. These code chunks are exactly the same as these code chunks, yeah. And so I'm going to switch back and forth between these two. This one for legibility, because it's a little easier to see and show, but I'm actually going to be running them here as code chunks in our studio. You can do it either way that you prefer. Okay, so let me catch up, make sure I have RSci3 installed. Yeah, let's do the Cytoscape ping. Great, it'll tell me I'm connected. There's a nice version. If you type Cytoscape into R and into RStudio, you'll see an autocomplete of a bunch of Cytoscape system information you can get. These are just 2 examples. These are good for ways, a good way to record in your script, for example, what version was run last time you ran it. All right, and now diving into the actual networks here. This first overview is beginning with a data frame. So if you use R, you use data frames all the time. We're making 2 data frames here, one for nodes and one for edges in this chunk. And they're pretty human readable, right? So here you need to have an ID namespace in this data frame, and you can give it the names of the nodes. And then anything else you add will come in as table attributes. And so we're going to add a group, a column named group, and these values correspond in order to the nodes that I've loaded. And I'm also going to load a score as integers. Yeah. And then in edges, you need to have at least 2 fields, a source and target. That makes sense. And again, they're just ordered lists. So I'm saying that node 0 connects to node 1, 0 also connects to 2 and 3, and node 2 connects to 3. Yeah. And then optionally, you can specify the interaction type. And this just comes in as an attribute in the edge table. Here I'm giving some semantics to the types of interactions. That's optional. If you have those set up, then this create network from data frames function, this is an RSci3 function that wraps together probably what would otherwise be 20, 25 lines of code into one simple function where you just pass in your data frames. You can specify a title and collection optionally. So if we run that one, again in this little mini view, we should see our network with the connections we specified in our edge data frame, and we see the attributes. Here's the integer scores and the groupings. And then in the edge table, we have our interaction type, and we also brought in an attribute called score. Does that first example make sense? Creating networks from data frames. And so hopefully all the R users, you're starting to imagine, oh, I've got data frames of I can read in a CSV file of my source and target nodes into R, make an edge data frame, and then with this one function, I can just load it up. The nodes data frame is optional because, right, you can imagine, as you can see, the edges actually have to specify the nodes anyways. And so you can provide only an edges data frame, and this function will also work, and it'll just create the nodes where necessary. But if you need to provide node attributes, like groups and scores, you need the node data frame. Okay. Changing the visual styles. Remember, there's a lot of different styles you can choose from that are built in or create your own. This one's sort of fancy, a fancy one called Marquee that creates this marching ants sort of pseudo animation showing you the directionality of the interactions. And so with one command, we can swap between any style, including styles that we create ourselves. Let's create one ourselves. So in the My Styles section of the vignette, we're going to define a few objects first, one with just a name. This is the key one, setting our defaults. Remember, this corresponds to this default column. And so we're going to specify a node shape, a node size, edge transparency, node labels. And then we're going to define a few mappings. This mapping is a pass-through mapping for node label, saying we want all the nodes labeled with whatever is in the ID column. Yeah. Node fill is a continuous mapping. Arrow shapes and edge width. And then here's the rSci3 function to create a style. You pass in those objects, and then again the same function to set that visual style. And so if we run this chunk, great, we have our new mappings on both edges and nodes. We have a new set of defaults. All of this information was set with these R objects. So hopefully everyone got this far in the pre-workshop, and with a bit of explanation. Or does that make sense? Because we're going to get more advanced here, and we just want to make sure we have the baseline set. Any questions so far? For those walking around, does it look like are people surfing the web? Are they looking where deep dish pizza venues are nearby? Okay, great. Okay, then maybe we'll pick up the pace a bit. Okay, for our users, has anyone used the GraphNel package for using graphs? It's sort of an alternative to iGraph. Yeah, I didn't think so. It's not that popular. It's the one Bioconductor provides. And so we have ways of creating networks in Cytoscape from data frames, which we just saw. There's also ways of creating networks from iGraph, if you already have iGraph networks, or if you have GraphNel objects, and that's what this example is from. So those are the three main ways of creating networks from sort of typical R objects. So let's just run this chunk. This one is creating a network from a graph, the GraphNel type. It creates the same network fine. Scrolling down in the vignette, we're now going to load table data. And so this is a very important function. This is the other one you'll use a lot, right? So you're going to read in CSV files to make data frames and then create networks from those data frames. You're also going to read in CSV files to create data frames that you then load as table data, right? Remember, Cytoscape treats networks and tables separately. Even if they're both coming from tables, you can use tables to make networks, and you can use tables to make tables. And so this is how you do the latter. You just have to pass in that data frame. There's a whole bunch of additional parameters that you can see that are optional. But in the very basic sense, if you have your column headers and your values specified, you can just run that chunk and load table data, and you'll see additional columns then load into Cytoscape. Those data are then useful, right, for creating styles. Here's other ways. These functions are even more compact for setting defaults than we did earlier. Single line functions that take care of all the rest of the code to change what these default column values are. And so there's over 100 of these alone, right? For every single type of node, edge, and network property, you have a dedicated function. And so you can find these in the documentation I'll show in a second. Again, we'll do a mapping, a node shape mapping, another consolidated function. You got to pass in which column you're going to use. We're going to use molecular type column, what the values are in the column, and what shapes you want those to correspond to. So this is a discrete mapping, not a continuous mapping, right? I want kinases to be diamonds, et cetera, et cetera. Fine, that runs. This is a continuous mapping of color. We're going to map color to log2 fold change. That's a common thing. Done. Node color mapping. This is an alternative node color mapping. And node size mapping.
I'm going to switch back to the HTML and show everybody where we are.
Great. Are most people doing it in HTML and copy pasting, or R Markdown? Okay, so in the HTML version, we went through up through 4 was part of the pre-workshop. So 4.1, 2, and 4.1 and 2. And then now we just did step 5. So step 5, 1, 2.
For those of you who are following along, we're about ready to start step 6.
Where is this R Markdown file?
This is how you get the R Markdown file. So if you say browse vignettes, rSci3, there's HTML source, in R script, you want source. And the source links, I would just download the source links, and that'll download as an RMD file, and then you can double click them and open them in RStudio. And that's how I got to here. Yeah, the RMD files are nice that way.
Which point are we on? We're on select.
We're actually on 5, this is 5.3.
5.3, if you're following along. Everybody caught up? We're 5.3. I see shakes of heads. I see blank stares. Okay.
Okay, great. So we've done network loading, table data loading, and style mapping a couple times now, right? And so there's a lot of other things you can do through automation, and that's what this 5.3 section, we can get into selecting nodes and actually pulling information from Cytoscape back into R, right? So you can select nodes by name with this sort of syntax, and you can see it in the UI. And now I actually have this information about the node identifier. Its unique identifier is now in R. And if I've done a selection through some other means and I want to see what I have selected, I can run this and it'll let me know I've selected node C. Great. Selecting first neighbors is a handy tool in Cytoscape that we use all the time. There's a nice function for that. From C, it then selects B and D. And then, of course, if I want to see what my selected nodes are, I can then pull them in as an object so I can keep a hold of those. So now I have this node SUIDs that gives me that list of selected nodes. And so hopefully you can imagine scaling that up. It gets a little more interesting, right, where you've made some node selection based on data values or based on first neighbors of nodes of interest, and then pulling those back in to R so that you can then create subnetworks, change the bypass visualizations on those nodes, right? And once they're selected, there's a lot of things you can do. And so these are some of the controls in our Cy3. So that's the overview vignette. I'll switch back to the HTML view, right? We just finished 5.3. I won't run these right now, but just so you can see them, you're welcome to run them. In 5.4, you can save your session. That's obviously important. If you just use this syntax, it's going to save it to where your Cytoscape is installed, which is not a great place. And so you'll want to usually provide a full path instead of just a file name into save session. And right, you can use the handy get working directory, for example, if you've set that properly in your R session. And so this is the recommended way of saving your session file, and you can do that at the end of a script, for example. In addition to the session file, which includes everything, the networks, the tables, the visual styles, everything about the UI, sometimes you want to just get the image of the network itself out. And so there's an export image function. Again, you want to pass a full path to that and then tell it what type of image you want. If you run ! export image, you'll get the man page. I'll go ahead and run that one. And in that manual page, it'll tell you your options. So there's JPEG, PDF, PNGs, PostScripts, and SVGs that you can export images. And when you do the PNGs, for example, you'll want to specify your resolution in your units or height and widths. So there's lots of ways of getting exactly the resolution and quality of image you want.
Typically, when I save a PNG, I'll use a zoom of 300%. And that gives me a really nice image. So whenever, when you're doing this, you don't really need to change the resolution, frankly, because it's just, that really doesn't matter. But I would always do a zoom of 300%. And then that makes a really nice image that you can send around. Clearly, it's not as good as a PDF, because PDF, all of your nodes are objects. You can zoom in sort of arbitrarily, but it's hard to mail around a PDF necessarily.
Yeah, 300's a magic number. It happens to be the exact same number I used to. It gives you a really large PNG. That's pretty much, it's good for publications. It's good for everything. Okay, now we're in the final section of this vignette where if you run help package, this is a standard R way of getting help for a package, it's going to list all the functions that are available. They're in alphabetical order, which is fine if you know what you're looking for. I just added this list of categories, which you saw the slide of earlier. They're now in the vignette as well, so that you can kind of help you find maybe sections that you're looking for if you don't know the name already. So the different categories of functions that are available, what they do, and then some examples that you can look up. So again, this isn't all of the functions. This is just sort of a sampling of the most common ones in each category. There's other ways to see what's available through automation. These two commands will pull up a web page. We'll pull up web pages showing you the Swagger documentation. If you're used to our RESTful interfaces, you've probably come across Swagger documents. I'll go ahead and run those. Pull those up, maybe. So there's two different pages. If you remember, there's SciRest and there's commands. So we have two different sets of API documentation. Here's another way where you can see the categories. These categories should look familiar. They're the same categories, the same structure we used in the R package itself. And if you open up any of these, you'll see the functions that are available. And if you open up any of these, let me open one that doesn't require attributes. Well, this is a good one. You can get all the information about what that function does. You can actually run it here in the web page. This web page communicates with your running instance of Cytoscape, just like the App Store does, and just like, literally just like the R functions do. This is a great way to, as you're writing your script the first time, to maybe test out a few functions and see what the parameters, what parameters are needed and what works and what doesn't work. Run it here, see the effect in Cytoscape, and then codify it into your scripts. So these two Swagger documents for SciRest and for SciRest commands are really helpful resources I go to all the time when I'm writing scripts. Question?
How do we find the network ID?
Great question. So there's a couple ways. In Cytoscape.
Can you repeat the question?
Oh, sorry. Yeah, I'll repeat the question. Was how do you find the network ID? So there's these SUIDs, session unique identifiers for nodes, edges, and networks. The network session ID, session SUID, is something you need for almost all SciRest functions. And it's sort of, if you've used Cytoscape before, you might never have seen it because we sort of hide it because it's sort of a technical parameter. But in the UI of Cytoscape, I'll start there. You can find it in the network table if you show it. So this icon will let you decide which columns to show or hide, and SUID is hidden by default, but I can just check it, and now I have the ID for Cytoscape. That's how you would do it from the UI. From R, I can also say get network SUID. So there's a function, hopefully an intuitive title there. And if I don't pass any parameters, it's going to give me the SUID for the current network, the one you have currently open in Cytoscape. If you pass in a network name, it'll give you the session ID for that network name. The network names are here, like My First Network and Simple Network. I could pass those in as arguments and get the session ID in case I might not know which network is current if I kind of have it in the background, or if I want to share the script and let other people run it. So these SUIDs are the same, and that's a parameter you often need to pass in functions. All the R functions allow you to optionally provide SUID. If you leave it out, it'll assume you're operating with the current network, the currently selected network. Any other questions so far? Yes?
So all the commands in R are running on the graphical.
Yeah.
So I guess when you have a really long code,
Yeah.
then it gets slower because it's doing it all the time on the, or not. I mean, my question
Yeah.
would be if there is any way to, if you don't care about the
Yeah.
you can just.
Right, I understand. Yeah, that's a good question. So the question was about, as I'm demoing it, and indeed as you have to run it, you need to have Cytoscape up and running with its full UI for this to be operational. And there's two parts to the question. One, how does that affect performance? And two, can you do it some other way? Yeah, it probably does affect performance a bit, but not significantly for any use cases we know of. I have a test script to test all the functions that takes about 4 minutes to run, and it literally changes every possible thing. I'll run it at the end of today because it's kind of fun to watch. I mean, the network panel just goes crazy for about 4 minutes. And so the performance isn't that bad, and indeed, it's a requirement. There's not a headless mode for Cytoscape yet, something we've been thinking about and wanting to do for a long time. But at this point, Cytoscape has to be up and running with its UI somewhere. It could be on some server at your institution, or it doesn't have to be on your local machine, but it does have to be up and running with a UI. Any other questions? All right. Let's see. So I want to go through one more vignette that gets a bit more advanced. This one was a toy example. We're going to go through a real example, and then we'll switch to the freestyle event where you can pick your own vignette. So the next one we want to run through is called the Cancer Networks and Data. Again, the way you find that is there are two ways. Which browser? Now I've got two browsers open. Great. Either from your browse vignettes that you run in RStudio, you can go back to that page and pick the cancers and networks. Or these are also available on the bioconductor page for RSI3. You can get the HTML version of Cancer Networks and Data, number 6. So I'm going to open that HTML version here. And then again, from the source link, you can get the RMD file and open up the RMD file in RStudio, which I have here. All right, so let's look at the HTML version. This one, again, installs RSI3. We've already done that fine, but this first chunk also installs the color brewer, which you all will want to have. So you can just run that chunk to get both of those installed and set via the library function. Again, it's always good to start with a Cytoscape ping to make sure we're connected, and we are. And then now we're going to dive into step 3. Of getting disease networks. And so we did this in a demo earlier using the UI, and this is how you do it via commands. Here we're going to get networks from string. Yeah.
Hey, Alex, I've got a bunch of networks on there. How do we start clean?
Sure. If you don't want to see these networks anymore, the way I like to do it is to just close the session, close the current session. So there's a function for that called close session. However, it has a safety feature built in. It won't let you run it without any parameters because it wants you to be sure that you're aware of saving what you've done so far. And so you need to pass in a true or false of whether you want to save what's in the current session. So if you just pass in an F for false, it'll just clear out and start a brand new session for you with one function. So that's a nice way to sort of clean the slate between work. Okay, so again, the string app, it's an app, it's not part of Cytoscape, but it's supported by automation because the app's author, happens to be Scooter, took a little bit of extra time to add support for commands, right? And that command syntax is produced here in the script. It's the same syntax that you would use in the command line of Cytoscape, and so we just need to define that as a string object, and then we can say commands get, and we can run any command that you would run in Cytoscape. You can run with commands get or post, depending on what kind of function it is. And so this chunk should now go to string. If we all run it at the same time, which we probably are, it might take a little longer than it will for you back at home, but it'll still work. And it's getting, in this case, we're doing a disease query, right? Not a protein query, but a disease query. And so we're just going to say breast cancer. And it's going to give the string database's current best model for breast cancer associated genes and the interactions between them. This model changes from month to month as string continues to calculate new data and update itself. And so if I run this now and I run it a month from now, I'll get a different network, which is kind of cool. But it means in your scripts, you'll want to record when you did this search and maybe store this information somewhere, because you can't get exactly the same network from string again. Or you might want to save it in index, for example, the cloud storage for networks, so you could save instances of the string breast cancer network over time, locally or at index. Okay, so that was the breast cancer one. Let's do that again and get an ovarian cancer one. So we have two different networks we can work with in this vignette. So it's this simple, right? You can type in whatever disease area you're researching on and get a network model this way. Now we have two, breast cancer and ovarian cancer networks in our Cytoscape window. Yeah. All right. Now to demonstrate some of the features, we can get a list of these networks at any time. It's going to give us the network names as an object that we can then reference in our scripts going forward, right? So we don't have to type these to avoid user error. We can perform layouts. There's a layout network function. So let's do a circular layout. There it is. As Scooter mentioned, this isn't a great layout. It really doesn't help you see much, but you can do it. All of the Cytoscape layouts are available via this argument, this function, except for the Y-files layouts are not available. We have a special license to be able to give free access to Y-files from the UI only. They sell their layout algorithms otherwise. If you're wondering which layouts are available from commands, you can say get layout names. Now this list changes depending on what you have installed. For example, I probably have one here that you guys don't have called Gene Mania force directed. That came from an app, the Gene Mania app that I have installed. It added to the layouts menu, and so it's now added to what's available from to my script. And so this list isn't a static list at all. It's a dynamic list depending on exactly the state of your local Cytoscape instance. So I can run, I can set all the properties. I don't know if we showed you the layout settings. We usually do. I think we forgot to demo that. Under layouts, there's a settings panel, and there you can control the spring coefficients and default masses for force-directed layouts, for example. Lots of different parameters for each of the layouts, and it's a nice way of tuning your layout. And so you have access to that via scripting as well. You can set any layout property and get the list of layout properties with another command. Or you can pass them in. So this will tell us the list of properties. Let's just show that. Force-directed has these available properties to tune, and then in layout network you can just pass those in, alternate values, and you'll get a slightly different layout. So here's force-directed with those parameters tuned. If I take a couple zeros away from here and run it again, it's a totally different network, right? I've tightened up the spring coefficient and made it a more rigid spring. If I loosen that up a bit, we get some sort of medium here. And so this is a nice iterative process of tuning these parameters. What you want to see is, nice grouping, but also nice separation. If this was all one tight hairball, it wouldn't be very interpretable. If it's too loose, it's not very useful either. But this is a nice medium where we can see, oh, there's kind of two subnetworks here that are tightly clustered, and then there's a few nodes that interact in between them. So that's the sort of tuning you want to do with your layout algorithms. Okay, now we're going to switch. Let's see, if we look at this view, we're in section 4 of interacting with Cytoscape. We did some we just did the layouts, and so now we're on 4.3, and we're going to go through these chunks and actually pull data from the table panel. Remember, the string app loads a ton of information into Cytoscape, and one of the things it loads is a disease score. When you do a disease query, this last column tells the association per gene with that disease that you typed in, based on a lot of different information. And so we want to pull these disease scores into R so that we can do we can plot them and do some selections using that information. And so that's what section 4.3 and 4.4 do. So let's run those. The first thing we're going to do is this function called get table column names, and that's going to tell us what's available. So these are all the columns that most of these were brought in from the string app, yeah. And we see there's disease score there. Okay, great. Let's pull in get table columns from the node table, give me the column disease score, and we're going to load that as a table in R. And so this object now, disease score table, has exactly what you found here, SUIDs, node SUIDs, mapped to score names, the exact information that came from string. And now we have it as an R object, right? So in R, you can do all the favorite things, all your favorite things that you might want to do in R, like plot. So we can now see the distribution of disease scores in this network from string. You can run a summary, right? There's lots of different things you might want to do. The summary looks like that. So we get our min, our median, our max, standard R stuff. Okay, let's use that information. So now we have this disease score table, and that first column has disease scores. And so let's get the top quantile. That's what this first line does. And then we're going to get the row names from that quartile, and then we're going to create a subnetwork and pull out only the top quartile of disease-associated nodes from this network. That's what this one chunk does. So we got a new network called, gave it a name, top disease quartile, and it's a subset. It's 38 of the original 150 nodes that are the most associated with ovarian cancer. Great. You can see some of them are connected and some of them aren't, right? So these were selected for their disease association. Given this confidence level of interactions, some of them don't have known interactions with each other. And so a little trick for getting rid of these, because there's nothing I can say network-wise about these, is to create another subnetwork and just say, create the subnetwork based on edges, and you can just say, give me all the edges and the nodes associated with them, and it's a nice sort of shortcut of getting rid of disconnected nodes, right? So I now have a subnetwork of a subnetwork of a subnetwork, and so now I have just the 25 connected nodes most associated with ovarian cancer. Going back to our original network with set current network, we're now going to select, we're going to create a different subnetwork in a slightly different way. So this was based on top quartile. We could also pick the top 3 nodes, again based on the disease score, and then get their first neighbors and create a subnetwork of that. So that's what this chunk does. Run that chunk, and now we have an alternative. You can see by the ordering here, we have an alternative top disease neighbors network that's based on the top 3 nodes and then their first neighbors were pulled out of this network, and we created a new one. Okay, that's an alternative way of making a subnetwork. And we have a third way here using diffusion. So there's a diffusion app that's built into Cytoscape. Here we go back to the original ovarian cancer network. We select those same top 3 nodes. I'll run these lines one at a time. So we're going to go to the original network, select the top 3 nodes. Do I need a clear selection? Did I do that right? There they are, top 3 nodes. Now we're going to run diffusion, and again, it's an app, so it has this. It has its own function now, but when I wrote this, it didn't. And so you can run diffusion app, run diffuse, or you can find the function called diffusion basic. There's diffusion basic, or you can pass parameters diffusion advanced. That's the same thing as this get function. So what it's going to do is not just find first neighbors, but it's actually going to think of it as applying heat to those 3 nodes and using the edges as heat conductors and seeing what heats up around it and selecting additional nodes around it. And I got an error. I might have done something to, let's try this one. There we go. The new function works, the old one doesn't. So if you got the same error I did, I'm not sure if that was due to some particular state that I was in, you can alternatively just run diffusion basic. I'll update this vignette with that anyways, now that there's a new function there. Is everyone getting a selection of, something like 15 nodes instead of 3? And then creating a subnetwork from that, and then you can do a layout on that. Oops, I messed that up. This is what happens when you go back to the UI and start clicking on things. Let me run that again. Are people getting better results than I did? There's no edges. What are you guys seeing? Raise your hand if you saw. Okay, good. That's what you should see. I think I did something weird on mine going back and forth. Who sees what I got? Only a couple people. Good. Who sees a proper subnetwork? Okay, more people. That's good. Oh, thanks. Okay, so in demo mode here, I'm going back and forth and doing the cardinal error of clicking on things, which when running a script you really shouldn't do, because then it can lose track of where you're at and what you've actually selected. So I think I messed that one up. But the point there was to show 3 different ways of getting subnetworks from this original network, right? We selected nodes based on their disease values. We selected nodes based on first neighbor function. And then the last one was a diffusion function to get different subnetworks. Question?
So is that like a general thing when you're using Cyres to just only use R and not click in Cytoscape while you're doing stuff?
Yeah, great question about whether you should, as general practice, only use, when you're using R, only use R and not mess with the UI. And so yes and no. When coming up with the script, I'll go back and forth all the time, but then as you're codifying it and you're testing it, yeah, you'll want to run it without clicking on things in between. Unless you want to put in, a statement there saying, okay, now I've seen scripts where people say pause and select a node that you're interested in, and then run the script from there. So that's one exception. Other than that, yeah, you don't want to do what I did here and go back and forth and click on things in the middle of the script.
The tricky part of some of this stuff is, remember Alex said that when you grab a network, if you don't give it an argument, it's going to get the current network. If you selected somewhere else, it's going to take that current network. And I think that if you write your script with dependencies on current selection, whether it's node selection, edge selection, or network selection, that's where you should be hands-off.
All right, and now we're on to the last section of this vignette. Should just take a couple minutes, but it's a really important one, right? So we pulled in network data. We showed how to use the data that we got to do some selection, sub-network selection. Now we want to visualize data on it. You could visualize your own data on it. In this case, I got some data from TCGA, the Cancer Gene Atlas, related to ovarian and breast cancer, mutation and expression data sets. And so we're going to load those in and use those to do visual style mapping. And so we're in section 5 of the vignette. Okay, so the first step is standard R stuff. We're going to load in. I went ahead and made R objects ahead of time of those tables, so that's what those 4 lines will do. And if we take a look at them, we have, for breast cancer, we have expression and mutation data. So these are data frames, tons of data in these tables now, yeah. And this function should save me from any clicking I've done. It's actually explicitly setting the current network. So we'll go back to the breast cancer network and just redo the layout. So we're there. And now we're going to load the table, data. So the expression data and then the mutation data are done in these two functions, and we should see, if we scroll all the way right in the node table, we'll see we've loaded mutation data and expression data with these 2 functions. Now, a subtle point about these, I made the data frame slightly differently because you'll see both types. One uses row names in the R data frame, row names as the node names. That's what the expression table does, in which case you don't, you can get away with just the data frame argument and telling it which column in Cytoscape, which column has the mapping, the names that map to your row names in your data frame. If instead your node names are one of the columns in your data frame, then you need to pass in that argument and tell it which column in your data frame has the IDs that map which column in your Cytoscape table. So it's just some key column mapping and whether you're using row names or not as your keys. So that's 2 types of function argument usage that you'll probably see. Okay, now that we have network and we have table data, you should all know what's coming next, visual styles, right? So this chunk is going to then set some defaults. So it's going to clean the canvas of all the string styles and give us a nice plain background that we're then going to paint our new attribute mappings on. First, the expression data. Here we're going to define the range of data that we're going to use, and we're going to use this R color brewer to choose our colors for us. We'll use this red-blue gradient. That way we know they're colorblind safe, and we know they're tailored for data visualization. So we're not picking ugly colors and colors that misrepresent the range of data. And then finally, we can use this function of set node color using the colors that we got from Color Brewer and the data values from TCGA. And there we have it, right? So this gradient, if we peek in style and file color, we define this color gradient in R without having to use the UI to get low and high expression values. And there's some genes without any values, and those are our default grade genes. So now we can do the same thing with mutation data. It's the same steps, so I won't go through them. I'll just run them. This whole chunk then did the same thing, but in this case it chose to highlight the most mutated genes, and it used the border color, border thickness and border color to express that. So these are the most highly mutated genes in this network based on TCGA and their expression, average patient expression, and node fill color, all on this network view. The last steps here perform the same subnetwork operations on the breast cancer network that we did on ovarian cancer. I think, again, using diffusion, which worked this time because I didn't mess with it. And so here's now a nice subnetwork view. You can imagine this being a figure in a paper where we have mutation data, expression data, mapped to a breast cancer network and focused on the most significantly changed and affected genes.
How's everybody doing?
What's that?
How's everybody doing?
Yeah.
We all That was sort of a quick click, click, click. But is everybody kept up? We doing okay?
That's the end of the vignette. The last steps there are about saving, so I'm not going to redo those. And so this is where we switch. I wanted to, I hope it wasn't too slow. I wanted to go through a couple of those and just explain how and when we use the different functions. So now you are free to go back to the list of all the vignettes, and you're free to do a couple of things. Either pick additional vignettes here that are of interest to you and go through them. There's some time estimates listed next to them. Sorry, this is so small. And we can help you if you get stuck. There's a lot here, including an index vignette that I recommend. You don't need, I would recommend skipping ones like this. This has to do with updating scripts that were written for an older version of RSI3, so you probably don't have to worry about that one. But otherwise, they should all be useful vignettes. Or from this slide, you can go to the R scripts here and the Python scripts there and run any of those and work through those as examples. Or third option is start writing your own script. So if you have an existing script and you want to pull in network analysis into it, we can help with that. Or if you want to start writing one from scratch, you have table data that's networks and annotation data. We can help you with that. So we're going to be walking around for the next half hour and helping you work through examples. And then we'll just have a thank you slide with resources and a survey that really helps for feedback. So we want to make sure we mention that before we wrap up the whole thing. So
Can you bring a big version of that network up?
yeah, this network?
Yeah. Now everybody can see it.
Okay, yeah, sorry, everything was small. Okay, so any questions, just raise your hand. I think we'll go one-on-one at this point and help you guys work through your vignettes or projects. Yeah, Dexter.
I just wanted to add that if anybody wants help setting up their index account for the index vignette, there's several index development factors.
Yeah, I'll just repeat that. It's a very good point. For the index, which was this cloud storage that we mentioned, you need obviously to have an account so that you can you can define networks as private or public, etc. And so to create that account, you'd go to nextbio.org. And if you get stuck or want any guidance with that, we have the index developers and creators here in the room. Dexter and Jing, for example. Anyone on the team can help you set up an index account. Thanks, Dexter. Okay, raise your hand if you're stuck, or otherwise we're just going to wander around.
I just have a question. If we have the data set like my graph object, right? Can we load it? I don't have it with me, but can we?
Yeah, I'll just. And when there's general questions of common interest, I'll come up here and just sort of bug everyone and show the answer to everyone. You can ignore me or pay attention if you want. So the question was about iGraph objects. And so there's two things. One is we have a vignette about Cytoscape and iGraph. So I'd recommend running through that one. And the short answer to your question is, I think I could see it, under the create network functions. For RSI3, we have a create network from iGraph. And the argument that you pass in is the graph object itself, and you're ready to go. And that should include all the nodes, edges, and node and edge attributes as well.
takes in interaction data from different databases and resources?
So you probably need to talk to the string folks about that. I'm not on the string team. I wrote the Cytoscape app, so that's I co-wrote it. I guess I'm not the only one who did. Nadia is over there too. But this will give you an idea on the species. Here, it's probably. Here's the species list.
Okay. Yeah. Should be pretty good.
Yeah, and we can find
And
this.
you all
There's two, obviously the standard one, but also Lorada. So
when you built this Java app or plugin, was it through, it uses the same thing, uses the RESTful API that StringDB has to pull the data? Okay.
actually, I'm using, so I don't know, I'm using a RESTful API from the Jensen lab, who's my collaborator, but there's their API.
Okay. Awesome.
Okay, and this is stringdb.org is the place that you would want to go and look.
StringDB also has network data, or is it just purely interaction data?
It networks interactions. It is effectively just interactions. It's protein-protein interactions from a number of different sources. Okay, it's the best way to look at it. I mean, typically, for most of these things, you think of network and interaction as the same.
Yeah.
That changes when you have something like index, which is literally, I'm going to give you, if you search for a series of genes, I'm going to tell you all of the pre-compiled networks that have those genes.
Okay.
It's not going to build a network from those.
When I talk about interactions, I mean, for example, I query, let's say, 10 genes. I want to know all the protein all the protein partners for that first gene and the second gene, and then I can build a network from that. So that would be string.
In string, what you would do is well, we can do the exact. Right.
So that was one single gene, and you pulled
I put in four. EGFR, P53, BRCA1, and BRCA2. Okay, and I think I asked it for 10 additional. Right.
Okay.
And this is at a 0.8, and then if you look at what you got out, you can scroll over here and to the edge table, and you can see there's the evidence for this interaction. So it's the overall score, it's the database's score, it's the experimental evidence score, co-expression, text mining, blah, blah, blah.
Okay. And that all comes through the API, the StringDB API. So, okay.
Well, I get it from Jensen Lab. I assume he's getting it from String.
So he has his own API that you use and use.
Because it's very tailored for Cytoscape. Because what I can do now, which the String API does not support, is I can take this node and then I can say expand that network. And what's happening here now is I have to take all of the nodes that are already in the network and all the edges that are already in the network, send it back so that it knows what I already have when I want to expand it. So that makes it a little different. The String API does not support that. The Jensen Lab API does.
And Jensen Lab, that's also, is that public and free? Or
It's public. I don't authenticate to it. Sort of need to, talk to Lars, Lars Jensen, as to whether you can use it.
for like an application that'll make a lot of requests.
Mhm.
Okay.
Well,
So Lars Jensen Lab and String DB API.
yeah.
Those are my
yeah.
go-tos.
Those are your go-tos, I think, for generating some of this stuff. The other thing to look at is Gene Mania has a new API out.
Yeah.
And that's a different, just basically a different approach. So that's another one that you can take a look at is Gene Mania. So the ones that are go-to right now really are Gene Mania and String. I just hear about that a lot.
Okay.
So
Okay.
String used to be in Cyquick, but they gave up.
Yeah, Sidekick is not that really reliable.
Yeah, it's not.
We used to be on. We are still on Sidekick, but servers often
Yeah.
very dumb.
And that was our frustration with it. I mean, we still ship Cyquick with Cytoscape. But it's just, the whole idea of trying to aggregate all of that data together, you just leave out so much. None of this data that I just showed you is in String. Is in Cyquick or was in Cyquick. So,
Thanks.
sure.
Thanks a lot.
So this, querying this string, so how do we make that?
Okay, string, protein query, your species, okay, good.
So is that's, I'm assuming that's.
Yeah, so what you're missing there, so the easiest way to do that is I would do it like that. So go to the command line, exit out of that, and then go tools, command line right, and then say help. Help string, space string, right, return. That's going to give you all of the string. Now you can say help string, protein query. And now that's all of the various strings. I don't think through the command it's actually done. I don't think you can do this.
I love it. So I don't think I'd be able to right now I'm not. It would just be interactive.
So we're not working on release 1.4. That's feature 1.5.
So is there a way to load it like manually here through the UPI and make sure it's on our?
Yeah, once you have it, you can read it in the file. Once you have it,
Load it in here, okay.
you can just read that network in R, you can add into it from.
So that's just maybe that's not so.
Yeah, just input the whole thing just like we did before. And then what you can do once you have it in there is, actually the way that I would do it, just like you can read the colors, any other visual property, you can read X and Y location. It's just the ability, our site really provides you the ability to read any quantity, any color or shape or anything else. X and Y are just properties, you can read them. Okay.
Is there a way to sort of import directly into our site where you just have Gotcha. So I guess like for future. Gotcha. So you can just open it. So I know I've done it before where right, exactly. So like I know you used to save these styles as like a new style. But if I just want to import just that information to my R site. So if I export that, there's a way to save it like a style. Is there a way to import that into our I guess as I
So you want to basically determine a hub, not
like if you could work with these lists, like
degrees. You just want to do. So, I mean, yes, there are ways of doing this. You can put things like that. I don't know the specific uses.
I haven't seen the actual guys in a second, but you know, and I want to actually like I feel like I look for things like the X and L
If you have a higher
versus the difference be like a get visual style.
average up. So you can lower on the value, appearance of those to the amendments of the groups. And then it would have the average value of the children. And then you can work your way up out of it. The group note stuff, if there's too many people dying, which is not, it's not as robust as the underlying. But it's certainly give it a try. So there's something called the sets app. And that specifically will do union, intersection, and differences. So it's set, it uses sets. And you can define those sets. So you can take a bunch of nodes, select a bunch of nodes, define that as a set. Select another bunch of nodes, define that as a set. And then you have the union as a stage. Just basically get a bunch of union. two branches. And then build your aggregation up manually from that. So that you have one meta node and another meta node, which is and then go ahead and do your
Some of you are wrapping up your projects or vignettes, so we just want to share last two slides. One is a thank you, and this slide has links to the manual for Cytoscape, a link to the tutorials page, which you should all know about now, the App Store, and then the most helpful link here is probably to the help desk. So lots of activity on this help desk. Ask any level of question, and it's guaranteed to be answered within a week because we answer it during our weekly meetings if no one's answered it before then. And then the very last slide is a link to surveymonkey.com r Cytoscape. If you guys can take 2 minutes to fill that out, that helps a lot. It's a short survey. We pour through that feedback and make improvements to the content going forward, so it really helps a lot. And also you can report issues for both Cytoscape, but also for the R program through GitHub. That'd be very helpful. And so we'll be here for the rest of the time to continue helping if you have additional questions, but just wanted to thank you before some of you headed out.